Hi, I'm Dimitris Haralambidis, and in this presentation we are going to have an introduction in linear functions. We'll start by giving a definition. A linear function is a function whose graph is a straight and non-vertical line. Any linear function can be written in the form f of x equals mx plus b, where m and b are constants. This form is often referred as slope-intercept form. A linear function, as a function, relates two variables x and y in a specific way. An essential property regarding the linear functions is that in any linear function, a constant change in x corresponds to a constant change in y. Right now, we're going to give the proof of that statement. All we need to show is that constant changes in x values produce constant changes in the y values. In other words, that linear functions change by equal differences, and that refers to the y values, over equal intervals, and that refers to the x values respectively. To prove this statement, we are going to use a slope-intercept form of a linear function. That is, as already mentioned, the form f of x equals mx plus b. We'll begin with two equal differences in the x values, which are represented by the expression x2 minus x1 equals x4 minus x3. Since we want to prove that these differences in the x values create equal differences to the corresponding y values, we need to prove that f of x2 minus f of x1 equals f of x4 minus f of x3. Thus, we start by the expression x2 minus x1 equals x4 minus x3. Next, we apply the multiplication property of equality, and we multiply both sides of this expression with m. So we have that m times x2 minus x1 equals m times x4 minus x3. Then we apply the distributive property. That is to multiply the m outside the bracket with each term inside of it. Thus we get that m times x2 minus m times x1 equals m times x4 minus m times x3. Our next step will be to apply the addition-subtraction property of equality. As you can see, we add and subtract at the same time in both sides number b, and we get that mx2 minus mx1 plus b minus b equals mx4 minus mx3 plus b minus b. Then we rearrange the terms, and we get mx2 plus b minus mx1 minus b equals mx4 plus b minus mx3 minus b. We still rearrange one more time the terms, and we place them in brackets, and we have that mx2 plus b minus a new bracket mx1 plus b equals bracket mx4 plus b minus mx3 plus b. The first bracket, mx2 plus b, is actually the f of x2. The second bracket, mx1 plus b, is actually f of x1. And so on, we come to the conclusion that f of x2 minus f of x1 is equal to f of x4 minus f of x3, which is what we needed from the beginning. So, once again, equal differences in the x values correspond to equal differences in the y values. For any questions about this presentation, you can leave comments down below, or you can contact me with one of the following ways, either on my email or in my Facebook page. Once again, thank you for your time.